All right. I want to say this is the last of the new material, and the rest is just practice with characteristics of quadratics, graphing quadratics, transformations of quadratics, and writing quadratic functions. So, when we're talking about writing quadratic functions, we're always going to start, well, we're going to start for now in the vertex form. Remember, y equals a x minus h squared plus k. Okay, so in order to write something in vertex form, first you have to identify the vertex. Okay, the vertex gives you h and k, right? And we can use that in the vertex form of the equation. What else we'll need is another point. And we're going to use that to sub in for x and y. And we're going to use these to solve for a. If you can't see a, so we've talked a lot in regards to the parent function on where we see the a value. So we'll keep talking about that. But some of us are just going to struggle with that, and this is our other option for finding what a is. So once we solve for a, then we use the vertex and the value of a that we find to create the vertex form of the quadratic equation. And then if they really want us to, we can rewrite it in standard form. Remember, standard form is okay. So looking at this example, where's my vertex? 4, 1. And we're going to pick another point. Let's pick 5, 3. So what we say here is that this is our value of h, this is our value of k, this is x, this is y. So when we're solving in the form of the quadratic, the vertex form, y is 3, a is what we're solving for, x is 5 minus h, which is 4, plus k. Okay. So then we solve our equation. Well, 5 minus 4 is 1, 1 squared, so is 1, so 3 equals a plus 1. So minus 1 from both sides, 2 equals a. So the value of a is 2. So now we can write it in vertex form. Y equals a times x minus h squared plus k. Okay. And then we can put that into our standard form. Remember, you can square the binomial. If you remember the pattern, good. If not, just expand and FOIL. So x squared minus 8x plus 16 plus 1. Distribute a. And simplify, combining like terms. And that's our standard form, so that's what we're going to put here. Okay. Domain of this function, remember, there's no context given. The domain is all real numbers, and our range has to do with that minimum value. So y is greater than or equal to the y value of the vertex. But one of our questions is, can you see a? So if the a value is 2, where do I see that in the graph? Remember that in the parent function, from the vertex going over 1 I always go up 1 because 1 squared is 1. But seeing as my a value is 2, I'll be multiplying that 1 squared by 2. So we go over 1 from the vertex, but instead we went up 2. So that's just trying to reiterate what we've been trying to see when we're talking about finding a in the graph. Okay. Let's do one more example. Don't see a graph, but they gave me the vertex and a point. So this is my h value, k, x, y. I always like to write my formula that I'm using so that I make sure I fill it in correctly. 1 equals a, what we're solving for. Y is 1. A is what we're solving for. X is 2 minus negative 1 plus k. Okay. 2 plus 1 is 3. 3 squared would be 9. So 9a plus 4. Okay, minus 4 from both sides. We get 3 equals 9a. Divide by 9. A equals 1/3 because 3/9 simplifies to 1/3. Okay, so my a value is 1/3, which means my, oh, what did I forget? 1 minus 4, that's a negative 3. So it's negative 1/3. So my vertex form is y equals negative 1/3 x plus 1, because it's x minus h, and that's a negative 1, squared plus 4. And then we can simplify into standard form. So y equals negative 1/3. We're going to square the binomial. X squared plus 2x plus 1 plus 4. Distribute the negative 1/3. Y equals negative 1/3 x squared minus 2/3 x minus 1/3 plus 4. Okay, we got to combine these like terms. Negative 1/3 plus 12/3, right? 12 divided by 3 is 4, equals 11/3. So my final standard form is y equals negative 1/3 x squared minus 2/3 x plus 11/3. All right, so now there's some u-tries. Remember that you're looking for the vertex and another point. Choose a point that you can see it goes right through the grid lines. Don't leave yourself guessing. For number 2, here is another good point. For number 3, they give you the vertex and a point. And for number 4, it looks like they give you the vertex and you might want to use the y-intercept. Okay, so try those 4. Go ahead and pause the video because I'm going to go through example E with you, and I don't know why it's example E. Okay, so try those 4 on pause and then come back when you're ready to talk about example E. So remember, you can go through the key on your It's Learning to check your 1 through 4. Okay, but for example E, they don't give me a vertex. What do they give me? They give me the zeros. Well, what are zeros? Remember that zeros mean x-intercepts. So they've given me 2 points that are included on my graph. And I'm just going to sketch the graph. So 0, 0, one of my zeros, and the other is at 4. 1, 2, 3, 4. So what does that tell me about my axis of symmetry? It tells me that my axis of symmetry is right between my zeros, where x equals 2. Then they tell me my minimum. Your minimum happens at your axis of symmetry. So I have another point right here. So they've told me that my vertex is at 2, -3. And that my other point could be 0, 0, one of my zeros, or you could choose to use 4, 0. But using that, now that we've sketched this, we've gotten our vertex and another point. See if you can find your value of a. I'm going to give you a hint. It's a fraction, so leave it as a fraction. And then come up with your vertex form and your standard form. All right, so solving for a. HK from my vertex, x, y from my other point. And I'm using 0, 0 because 0 is always more friendly for me. So 0 equals a, what we're solving for, 0 minus 2 squared minus 3. 0 equals -2 squared is 4. Add 3 to both sides. Divide by 4. A equals 3/4. Okay. Which makes sense because over 2, normally I'd go up 4. I only went up 3. So I went up 3/4 of what I would normally do on the parent function. So my vertex form, y equals 3/4 x minus 2 squared minus 3. When you expand that, or simplify that, rather, x minus 2 squared, x squared minus 4x plus 4 minus 3. Okay. Distribute your 3/4. So we end up with y equals 3/4 x squared minus 3x. And I just want to tie this to the zeros for a second. Remember when we talk about solving a quadratic, we're talking about the solutions where y equals 0. We can do that by factoring and using the zero product property. So if I factored this, we'd say 0 equals x times 3/4 x minus 3. X either equals 0 or 3/4 x minus 3 equals 0. Add 3 to both sides, multiply by the reciprocal, x could equal 4, which gives us our zeros. So that's just tying back to solving by factoring.